So today I'm going to go over what Spearman rank correlation is. In science we use statistics quite a lot. This will help you during Unit 3 of the QFC BTEC Unit 3 Applied Science, which is independent investigation. Okay, so for one of the pass criteria, you will need to do this. Okay, or at least do one of these statistical tests on the data that you collect. Right? This is one of the tests that you can do, which is Spearman rank correlation. Okay. So what can this test tell you? It'll tell you whether or not there is a statistically significant correlation between two measurements from the same sample. Okay? Between two measurements from the same sample. If the correlation is negative and if the correlation is positive. You may have seen this before at GCSEs. It's where you do a line of best fit through some data and you describe the correlation. But instead, we're going to work out the coefficient. So the coefficient is R, and it will give you a value. Okay? And so it looks something like this. So you can have a number between -1 and +1. Okay? -1 being a negative correlation, +1 being a positive. 0 is where there is no correlation at all. And if it's halfway, then it's sort of slightly negative and slightly positive. Okay, so as an example I have here, I have 10 students. Okay, and we're going to compare their math score and their biology score. Right? So the question is, does being good at maths make you better at biology? So we're going to explore if there is a statistically significant correlation between these two sets of results. Now, because this is going to help you during Unit 3, I would suggest you help yourself, okay, so that there is less to do later. And I'm going to show you how to create an Excel spreadsheet so that when you get some data, you can just plug it into this, maybe change things around a bit, depends on how much data you actually get. But yeah, you'll be able to change the data and the values should automatically change for you. Okay? Alright, so this is how you calculate Spearman's rank correlation coefficient. Okay, there is supposed to be a bracket there. Right? But for now, all you need to know is N is the number of individuals in the sample, and D is the difference in the rank between the two measurements. Now, what the hell am I on about? What do I mean by rank? Right? And I will come on to that in a bit. So H0 is our null hypothesis. Okay? This is where there is no statistical difference. Yeah, H0, there is no. It's null. There is no significant correlation between math scores and biology scores. HA means that there is a statistically significant correlation between math scores and biology scores, right? If the RS value exceeds a critical value, then you can reject the null hypothesis. Let's not forget, a negative RS value implies a negative correlation. And a positive value for RS implies a positive correlation. Right? So step 1, rank each data set. Okay, right. This is where you need to go into Excel. Right? So in Excel, I already have this set out. Just going to zoom in, there you go. Okay, so I've already got my 10 students and I've already put in their math scores and biology scores. Right? Now, in between these two, I need another column. So I've selected the whole row I'm going to right click, I'm going to go insert. There you go. Okay, and I'm going to name this rank. Rank. Okay. Right. Now, what the hell do I mean by rank? Basically, what you're going to do is you need to notice how many data sets you've got. Okay. So here we have 10. So 10 is going to be the highest rank that we can give. Okay. So you're going to start from 1 and rank up to 10. Now, 10 implies the highest. So the highest number in your data set is going to be 10. That's 98. Okay. Just look at the math scores for now. Your lowest score is going to be 1. So, yeah, that's right. So, 1. Okay. Now you can start from either end. But I'm going to fill this in. Okay. Of course, I've already done this off camera. Right, so that's all fine and dandy. That's nice numbers, okay? So we're going to do the same for the biology scores. Again, highest is going to be 10. Lowest is going to be 1. Okay? Now, you may notice something about this data when you're coming to do 8 and 9. And that is that there are 2 numbers that are the same. 2 85s. Okay? This causes a little bit of a problem. It's not much, but it causes a little bit. But basically this means that they're going to have the same rank. Okay? They're both going to take up rank 9 and rank 8. However, they need to share the same number because they are the same number. Okay? So these are going to take ranks 9 and 8. 8 and 9. 9 and 9. Because it needs to be the same number, they're going to... What's in between 9 and 8? It's 8.5. Yeah? So they're both going to be 8.5. Now, for instance, if we had a third number that was the same, okay, this is going to take up 7, 8, and 9. 7, 8, and 9. Okay, they're taking up 3 ranks. They're going to share the same rank, and it's going to go in the middle. So what's in between 9 and 7? 8. So all of them are going to share the same number. They're going to share 8. Okay, that's just in case you come across it again, like in the future. Okay, so I'm going to put that back to 56. I'm going to change these back to 8.5. Okay. Alright, and then the rest of the numbers are actually nice. So second one is 83. No, the next one is 83. Right, but don't forget ranks 8 and 9 have already been filled. So 7, yeah. And then 6, 5, 4, and then 3, 2, and then 1. Okay. Right, so we've done our rank, done the ranking. Now we need to work out the difference. Okay? I'm going to work out the difference. And this is the difference in ranks, not in marks, difference in ranks. So equals. rank 3, take rank 7. Make sure you highlight the cells because this will be key for when you input your own data. Okay, now because we're going to copy the same folio all the way down, you can make that cross black. Okay, so just hover over that little square there, click and you drag all the way down. There you go. Okay, now we need to work out the square of the differences. That's just difference squared, right? So D hat, so that little hat key, that's just shift and 6 and 2. Okay, and do use that again. So shift 6, 2, enter. And again, we're going to use the same formula so we can drag it down. Okay. Now we need the sum of the square of the differences. So all these numbers need to be added together. I'm just going to put in a symbol, okay, which is this one here. It's a Greek capital letter sigma. If you wanted to find this, well, without scrolling through, see this character code 03A3. You can paste that into there, and it'll automatically pop up. Okay, here we go, sigma D2. Okay, I'm going to highlight this. There we go. Right, so equals sum. I'm going to tell it to add it all together. I'm going to click and drag. You can't really see that very well, can you? And then enter. I'll just turn that into a different colour because I can't see it. There you go. Okay. And that's 68.5. Is that correct? Yes, it is correct. Woohoo! Right. Now we need to plug in the numbers. Right. Okay, so why is this? Right. So we've worked out the sum of the differences squared. Okay, so that's going to plug into here. And n is 10. Okay, and you can do this in Excel as well. I'm just going to zoom out a bit just so I've got enough room. Right, so RS RS. Okay, so it's easier to do top and bottom first, just so that you don't get confused with all the brackets and everything that's going to be happening. Right? So in the top, you've got 6 times by 6 times 68. Oh, sorry. Okay, so 6 times 68.5. Yeah, don't forget, click on the cell. Okay. And on the bottom, you're going to have 10. Okay, so there's 10 people here. So I guess this is the only cell that you're not going to highlight. Yeah. And cube it. So hat, and then 3. And then you're going to minus 10. There you go. So that's top and bottom. RS. Okay. Equals. Don't forget the 1 minus, open the bracket, that number, divide by that number, close bracket. Okay. So 0.585, and that's what we've got. Yep, so that's correct. Okay. So now we've worked out RS. What about our hypothesis? So we're going to take this value. Okay. I'm going to take this value and we're going to compare our value to a table. Okay. Table of what's called critical values. So make sure it's a relevant stats table. Right. For n is equal to 10, about 10 pairs, and p is 0.05. This means that we are 95% confident when we are making this assumption. Okay. The critical value of RS when p is equal to 0.05 and the number of pairs is 10 is 0.65. Because this is below the critical value, so the critical value is 0.65 and our value is 0.585. It does not exceed this critical value, it is below the critical value. So we must accept the null hypothesis H0. There is no statistically significant correlation between maths scores and biology scores. Okay, so just because you're better at maths does not mean you're going to be better at biology in this instance. Okay, and that's it. So if your experiment is something like this, or even if you just want to try and use Excel more, then this is it. So now when you change the exam score, so say if this person got 4A instead, then it should change. Should be in the keyword. Okay. So now if this is 40, then this is going to be our last. Okay. There you go. So now it's changed slightly. Everything's changed slightly. Everything's changed. Yeah. So it'll update according to whatever you change. And that's it. That's all I've got. Thank you very much.